Right, so I learned a little while ago that the best way to get a talk accepted at an event is to mention the word Docker. So I did that again this time and it got accepted. The second thing I learned is write a really long excerpt that doesn't actually mean anything. And then you can talk about whatever you want and no one really knows you didn't. So I ended up with this big bunch of buzzwords and this is actually what I'm going to talk about, and it's accepted, so I can talk about whatever I want. I am kind of covering what I said I would, so that's kind of a good thing. So my name is Czarkowski. I am a cloud engineer at Blue Box, which is now an IBM company. I think I'm supposed to say contractually. I worked at large enterprises for a very long time. I left so that I could go and work for a small startup, and then I got bought by IBM, so I'm back. And I've been working with OpenStack since about Folsom, and I've been working with Docker since 0.3. I actually had a personal app in production on Docker at 0.3, so I've been doing it a while. And I've spoken at both the OpenStack Summits and DockerCon about this kind of stuff. I wanted to do some audience participation, make sure everyone's awake. So put up your right hand if you're currently at an enterprise of some size. Keep that hand up if you're currently running OpenStack in some sort of meaningful way. I'll let you choose what meaningful means. And then put up your other hand if you're doing something with Docker in a meaningful way as well. So all those people with two hands up, they're the people you want to network with later today at drinks, etc. So I am going to start a little bit off topic, but it kind of comes back in and talk about bimodal IT for a little bit. I think it's one of the most important things that an enterprise needs to be doing, bimodal IT. And the lack of bimodal IT, in my experience, is where a lot of enterprises go wrong. Bimodal IT is a kind of a word that sprang out of Gartner like in the last year or two, but the concepts have been around for a while. They just like to name things so they can claim ownership. So your mode one is your legacy IT business, and I don't mean legacy in a derogatory sense. I just mean it's what you've got, what you've had for, possibly 10, 15 years to like today. And your focus from that mode one of IT is on the maintenance of that, and it's through reliability through business process. So you're talking about using waterfall for project planning. Talking about ITIL and change committees and like those 12 a.m. to 6 a.m. maintenance windows. You've got Exchange servers, physical servers. You're running Windows 2003. You're running like RHEL 4 with satellite server. That sort of stuff. And it's a very ticket-driven infrastructure. So you submit a ticket, you ask for something to be done, and you say you want a server, and sometime between an hour from now and a year from now, a server shows up and you can use it. It's really the pets versus cattle mentality analogy, since we've talked about that a fair bit. Improvements here, you want to focus on, if you want to focus on cutting costs and stuff like VMware is great here because it's great for running pets. But a lot of these apps are not cloud native, so they're not necessarily great to try and drag into OpenStack. And so that's where you have your second mode of IT. And this is the forward thinking, the planning what you're going to be doing in the future. This is the way you're looking at PaaS and OpenStack and cloud in general. And it should really be a completely different part of the org to the team that's looking after kind of your legacy infrastructure. And your main focuses are on reducing bottlenecks, theory of constraints, stuff like that, and delivering business value. And you're using, Scrum or Kanban, hopefully Kanban, especially if you're an operations team. You've got some sort of DevOps practice in-house. You're doing infrastructure as code. You're doing continuous integration, maybe continuous delivery, etc. And you're using like cloudy things. You're using Google Apps. You're using Slack. Using Amazon or OpenStack or whatever, containers, and any number of as-a-service products. And you're providing a self-service IT infrastructure to your organization. So instead of filing a ticket and waiting, they're hitting an API or hitting a web UI and getting whatever they've asked for within a few minutes rather than a few months. And this is definitely the cattle of the pets versus cattle. And without the second mode, I think your business is going to suffer. There are a lot of large enterprises that are doing this kind of thing right now, and they're going to accelerate past those that aren't doing this. And some symptoms of not doing bimodal IT is if you get involved and you do a 3-year cloud RFP, RFC kind of process. And if you do an RFP for cloud, you've kind of already failed. Asking things like, whenever you're looking at new tech, how can we do everything with this? Like, how can we migrate our entire workforce into this and all our workloads into this? That's, it's never going to work, and you're always going to be chasing your tail, and you're never really going to move forward. And then also building a goal or a company-wide metric of how many systems have we virtualized this month, and that just leads to people doing things like one-to-one virtualization or putting a database and both of its read slaves on the same hypervisor and stuff like that, because you're just trying to meet a metric rather than trying to make a meaningful difference. If you haven't read these 2 books, I highly recommend them. The second mode of IT is should be very focused around the theory of constraints, the lean manufacturing, Toyota practices, that sort of stuff. And then, so these are the 3 ways of DevOps they're talked about in the Phoenix project. There's a really good blog post from John Willis, Docker and the 3 ways of DevOps that you should read. And basically, done right, the second mode of IT will start traveling through these ways of DevOps, and they'll start dragging the mode 1 of your IT org through it, as well as things start going from new to maintenance mode. And so at some point, in a few years or whatever, the 2 modes of IT are going to start to look a lot alike from a process and tooling perspective. And it's just the focus on maintenance versus new. I don't know why I put a photo of Nick Cage here. I guess I just wanted a photo of Nick Cage in my slides. So from that, we're going to talk about OpenStack a little bit. As we've all been talking about today, it's pretty hard to install. It's even harder to operate. You have to make a lot of choices when you want to run OpenStack, right? From the start, which operating system do I want to run? Most people are using Ubuntu. It's a predominant OS in CI, so most of the testing and stuff tends to happen in it. Although Red Hat is starting to get a larger share of that, so it's definitely not something you want to throw out of consideration. You probably don't need to pay your OS for support. I don't know about you all, but I've never really had much success or much need getting good, timely response out of my OS vendors to make it actually worth paying for it. And then which OpenStack distribution? So obviously you've got your OS native stuff, from Ubuntu or from Red Hat or whatever. Then you have Helion and Mirantis and those kind of other, they don't have an OS, but they have their distribution. And then you've got your options of installing from source, which is actually a pretty good option, and also rolling your own packages. At Blue Box, we do roll our own packages, and we use a tool called GiftWrap, which is open sourced. And so that basically rolls packages out of source. And it's super useful if you have your own patches that you want to put in and your own forks you want to put in. One of the problems with using OS distro packages is you almost always need to patch them to do something special for you. And then you're fighting the packages all the time on who owns the code that you've just patched. And it can be really, really messy. This has already been shown once today. I thought that was pretty good. This is the logical architecture diagram from OpenStack. And you can see there's a lot of boxes here. And inside those boxes, there's lots more smaller boxes. And each of those represents 100 or more configurable options, of which you probably need to set 10 out of each 100 to get a working OpenStack that works the way you want. There are no opinions in OpenStack, so you kind of need to bring all your own opinions. You need to choose what database you're going to use, what message queue you're going to use. Am I going to use MySQL or Percona or Postgres or Oracle or some other crazy stuff? Rabbit versus ZeroMQ. And then you come to networking, and there's a ton of choices, right? You're going to do, hopefully you're not going to do Nova Network. You're going to do Neutron. But are you going to do OVS or are you going to do Linux Bridge? Are you going to do, from your tenant networks, you're going to do VLANs, VXLAN, you're going to do GRE encapsulation. There's a ton of questions. And when you're first installing OpenStack, you don't even really know what you need out of those things. And then, of course, compute, you've got to choose your hypervisor, whether it's KVM or Zen or VMware or something like LXC or something like that. And then if you want block storage, again, a ton of choices there to get block storage. So my recommendation is if you're pretty new to OpenStack, pretty new to cloud, and you want to run OpenStack, cut out at least half of that diagram and focus on just the core components, which are, to my thinking, Horizon, Keystone, Nova, Neutron, and Glance. And that's just enough OpenStack to get you, a useful cloud. And then for MySQL and Rabbit, that's what you should do for database and queuing. And initially, you probably don't even have to worry about replication or HA for those. You can solve that later and bring that in. Just make sure you back up your database. Messages are cheap, so it doesn't really matter if you lose a few messages if Rabbit dies, but you don't want to lose your database. For your network, I really recommend starting with like a single externally routed tenant VLAN so that you don't have to worry about initially setting up the Neutron layer L3 router and HA for that, and don't worry about doing floating IPs and stuff because you're probably going to be running this only internally for now, and so you don't need to worry about public accessibility and stuff. So just keep it simple. All the SDN stuff can come later once you've got a handle on the basic cloud. And then I put a question mark on Cinder. If you already have a NetApp or something that you want to keep using, then it might make sense to start using Cinder pretty early on. But there's no real rush to do it. It does give you a bit more ability to do your stateful data like databases and stuff if you want to keep those running. But if this is a dev test, you probably don't care too much about that just yet. So hold off on Cinder for a few months until you get a hold of the rest of it. And then you need to figure out what you're going to do for config management. If you want to stay in repeatable OpenStack, you really need to use config management. There are a lot of commands you need to run in a particular order, and trying to do it from a script that you've pasted from a wiki, you're going to get things wrong and it's not going to work. So there's a bunch of options out in the OpenStack and StackForge repos. So whatever your config management flavor of choice is probably what you should use. Or it may make sense in certain circumstances to roll your own, but one of these should probably cover you. At Bluebox, we actually rolled our own because we have some pretty specific use cases. We call it Earthshiller. It's Ansible based, and unlike a lot of the ones on this list, it is super opinionated and it's curated for our particular use case, which is running lots and lots of medium-sized clouds for lots and lots of customers and operating them. So we have a very particular use case, so we are super opinionated, and while we're super opinionated, it's a pretty good, solid set of opinions, so they're applicable to probably a lot of people. So it's open source, it is freely available, and if you're looking to use something, I think it's pretty great. We have feature flags to enable and disable optional items, and it's all our development environment for most of us. We use Vagrant, so our Vagrant story is pretty strong, so if you want to kick the tires, you can run it against Vagrant and have an environment stood up in 30 minutes or so. There are a lot of tasks, so we have we call it Just Enough OpenStack for Docker. It's an environment that you can stand up in Vagrant, and even just that, which is just this cut down stuff, is over 1,200 Ansible tasks. So that's crazy if someone wants to try and do that manually. Shameless plug, I think Jesse's pretty much already covered this, but we will manage and operate your cloud for you so that you can focus on working with it and running on top of OpenStack. I'm talking a lot faster than I was when I was practicing this. So on to Docker. Let's talk a little bit about what Docker is. Just make sure everyone has a pretty good idea. It is, at its heart, it's process isolation. Or a lot of people call it cheroot on steroids, which I think is a pretty apt description. It uses the Linux kernel tooling to do that process isolation. It used to interact with LXC, but now it goes directly to the kernel tooling, C groups, namespaces, etc. And it creates shareable and immutable artifacts in the form of Docker images. And those can be shared via the Docker Hub or via a private registry. Inside of that container, you can have as little or as much of an operating system as you want. And they almost always have super fast startup times. It should never take more than a second to start a Docker container up. When it does, it's usually because whatever app you're running inside of it takes a while to get started. And I've seen anything from a couple of meg in size, where it's just like a Go binary, so it doesn't need much OS, to a couple of gig when it's like a large Python app that has a lot of system dependencies and stuff. This is your kind of standard VM versus Docker diagram. I think I stole it straight from the Docker website. Your containers aren't virtualization, but you can make them act like a VM. And if you use something like Nova Docker with Nova, that's exactly what that is. It makes your container act like a VM. Your security/isolation is somewhere between chroot and a VM. So if you're just one org and you're all pretty friendly together, it's mostly okay to run containers from different groups in the org on the same machine, talk via the same Docker daemon. If you're in a multi-tenant environment or you have applications with different security requirements, then you don't want to share that same Docker daemon, because there are definitely ways to get back to the root system and start messing around if you know what you're doing. It doesn't have quite the isolation that a VM does, or like with the Solaris zones would have. Any operating system capable of running Docker can run your Dockerized app. So even if you're running, say, Red Hat on your server, and you have an Ubuntu running an app inside the Docker container, it will just work because it's sharing the kernel, and the kernel is shareable between the different OSs for the most part. And it has this layered file system. So each you run a bunch of commands when you're creating a Docker image, and each one of those commands creates a layer. And so what you end up is with not only are you able to share these images, but these images are able to share layers inside. So that diagram we've got up there, I can't actually see it. I can look down there. You've got your two Docker containers. Each have its own separate bins and libs, and each has its own separate app. So if they're both Python apps, they can actually share that bins and libs layer, which means the difference between the two containers might be just a few megs. So you run the first one, it might need to load 500 meg from the Docker registry. It might take a while. You run the second one, and it's going to reuse most of those same layers. So it's a few seconds to just get that little bit of difference. And this is what a Docker file was. It kind of looks like a bash script. It's not really. It's a little bit more sophisticated than that. And it's basically the instructions to tell Docker how to construct your Docker image. This example is actually pulling from a Chrome image and deploying my slides, which are showing here, into that. And then you can see the entry point command is telling it to run Chrome and go straight to my slides. And I share my X device in when I launch the Docker container, and then I get an actual graphical Chrome showing up with my slide deck in it. The next step up from that, I think, is Docker Compose, and that's when, from a development perspective, you start to really get some good usefulness out of it. You're using a YAML file to describe a manifest of Docker containers that you want to run. You can see I've got 3 here: Nginx, HHVM, and MySQL, so it's obviously a PHP app. I'm doing a volume mount into the Nginx and HHVM so that any changes I make locally will get changed inside the container. So I have like an instant feedback loop when I'm actually running it. And then I have links between them. So you can see the Nginx has a link to MySQL and HHVM. And so that creates a bunch of environment variables to give inside the container hints about where to go to access them, as well as an entry in the host file. So my config in my Nginx just needs to point to MySQL, and it will know where to go to find it. I can also put in environment variables. You can see I'm telling what ports to share, etc. So if I ran Docker Compose up on this, within a second I would actually have my PHP app with the database and the 2 application layers up and running very quickly. And that really cuts down on the feedback loop. I want to quickly talk about Factorish, but I don't want to go into too much depth about it. It's a set of tooling I developed to run a legacy app inside a container and make it act more like a 12-factor style app. If you're not familiar with 12-factor apps, if you go to 12factor.net, it's basically a manifest on how to write cloud-native apps. It's been around for a long time. It sort of grew out of Heroku, and most of the things are pretty relevant across any sort of cloudy app. And so this allows you to it ties together a bunch of tooling to help with doing config templating, process management, and service discovery and stuff like that. So a good example I have is the elk stack, and so it will actually stand up, say, 3 Elasticsearch nodes. It uses service discovery for them to find each other, so they cluster up, and then it launches a couple of Logstash nodes. They find it and start outputting whatever logs. They listen on syslog or whatever, and then Kibana shows up as well, and it knows where Elasticsearch is because of the service discovery, and it starts working as well. So you can start to put together some decent composable applications, even though they're maybe not really Docker native applications. You want to run Docker on top of OpenStack. I usually use Ubuntu Trusty if I'm trying to do more than just Docker. If I want to also run like a database or whatever in user space, Or if I'm doing just Docker, I'll usually use CoreOS because it's a bit faster to start up. Bunch of ways to use Docker with OpenStack. I'll talk through some of them in a bit more detail than others. The first one, Dhaka Machine. This has actually started to become super useful. Basically, I mean, you could just spin up an instance in OpenStack, right, and SSH in and start using Docker, but you lose a lot of functionality, and it's not very useful because you don't have access to the tools on your local laptop and stuff like that. So what Dhaka Machine is, it helps you do that, and it helps you do it in a more secure way and get some more of the Docker features going through. And what it will do is it will spin up a new server. It will install Docker on it if it doesn't already have Docker on it, and then it will set up a client-server key pair so that only you can talk to that Docker daemon, so that it's not such a big deal that it's actually exposed to potentially the internet or to a wider network than just your local machine. It does read your OpenRC style config files. So if you have your OpenStack environment variables set to access like Nova and stuff, it will read those and get your OpenStack creds. And it has a bunch of other stuff you do need to give it, which can be painful to write. I usually hide them behind an alias or a function or something, but I wanted to leave it up here so that you could see all that's needed. So you can see I'm saying create, I'm using the OpenStack driver, I'm giving an image ID, which in this case is Ubuntu, a flavor, I'm telling it what my internal network and my floating network are, what user to SSH as, and what security group to use. That security group is exposing the SSH port, the Docker API port, and then the Docker ephemeral range of ports. So when I launch a container, I'm able to get through to it. That'll run through, it'll print out a bunch more text than is up here, and it's finally finished, and it tells you to run a Docker machine command to access your Docker. And so you run that, and it gives you a bunch of environment variables to export. You eval that, and then you can run a Docker PS, and that Docker PS is now running against that cloud server. So it's then super easy to run a container on that. See, I've done Docker run, give it a name Nginx, using the Nginx container. Wait a few seconds. I grab the host port that is mapped because I didn't specify to map a specific port to it. And I can curl that, and I'm accessing Nginx. That's super useful. It supports, Docker Compose supports it, so you can actually layer Docker Compose on top of Docker Machine, so you can actually start your complex application using Docker Compose and share that out with other people rather than just doing it locally on your laptop. It supports Docker Swarm, which is kind of the new scheduling/orchestration tooling that Docker is building out. I haven't played with that too much, so I don't have too much to add about it. One thing it's missing in most of its drivers is being able to do host volumes, and that can be a little bit painful for development, but it's still great for doing like testing, staging, and doing demo kind of stuff. Next, I want to talk about Deis. It is, in my opinion, it is the most mature of the Docker-based PaaSes that are out right now. It has a Heroku-inspired workflow, and throughout its life, it's been around for about 1.5 years now. It's kept that same workflow. Originally, it was a bunch of chef cookbooks doing some magic with data bags to actually perform the work in the background, and it just gave you this Heroku-like interface to work with it. And since then, as CoreOS have come out and a bunch of other tooling, they've switched across and completely changed the underlying tooling, but their user experience is still the same. And that's super interesting to me because anyone that I had using it 1.5 years ago, everything they were doing still works exactly how they expected. It is now, as of itself, a distributed stateless set of distributed applications, stateless applications. It's all done inside Docker containers itself, and it uses CoreOS and the CoreOS tooling to kind of manage it. Another thing I like about it that I think makes it interesting for enterprises is it kind of has a separation of responsibilities mindset, where your operators, you manage the underlying infrastructure and manage Deis itself, and then your finger quotes DevOps team and your developers actually managing the apps that they're developing and deploying on top of Deis. And then also, it doesn't try and solve your data storage. It doesn't try and run databases for you because that's actually really hard to do in an automated fashion in a way that doesn't lose your data every once in a while. So it says you probably already have a team of DBAs and sysadmins and whatever that are very good at spinning up databases and setting up credentials and stuff. So you probably can very easily get the automation for doing that stuff outside of Deis. And it has good docs for running on OpenStack, which is pretty important. and it's pretty simple to set up and run on OpenStack. I want to show you just how simple it is to use. I was going to demo it, but I was concerned about the internet, so I decided to just show it up here. So basically, there's an example app that I've just cloned down, and I'm running Deus create. When I run Deus create, it is basically, it sees that I'm inside a directory that is a Git repo, and it creates a new remote, a new remote called Deus that points at a Git server that Deus hosts. And so when you do a Git push to the Deus remote, it will upload your application, and a bunch of post-commit hooks will then go, okay, this looks like a Ruby app. It has a gem file, so I'll install your gems. I will put your app in there, and then you've got a proc file which tells me how to run your app, so I know what I'm doing. And so it will then create a Docker image, it will version that image, and it will run that image. And it uses dynamic DNS, much like Heroku does, to then give you a URL that you can access it via. And then once it's up and running, you just simply curl that, and you get your response. This example app is just says powered by Deus and tells you what container ID it's running on. There are a bunch of commands you have, just like in Heroku, to then deal with configuration inside your container, like telling it where to point your database at and stuff like that. And that's all done with environment variables in a final layer inside your Docker container. So I can run here. You see I'm running Deus config set. I'm setting powered by equals OpenStack. And then it creates a new image, creates a new layer on that image, which is the environment variables, and then starts up the new container, switches the load balancer across to the new container, and then turns off the old container. And you can see there it says, instead of saying powered by Deus, it now says powered by OpenStack. And you can see it's got a different container ID as well. So it kind of does that A/B style deployment for you out of the box, which is pretty useful. And then if you're expecting a lot more traffic, it's pretty easy to scale it up. You just say, Deus, I want 3 of these, or Deus, I want 8 of these. And it will either scale it up or down to that number you've asked for. Super useful if you have like seasonal traffic. If you know between 6 p.m. and 9 p.m. that you get a lot more traffic, you can set a cron job or something similar to a cron job to say, hey, Deus, scale me up to 10 at 6 p.m., scale me back down to 3 at 10 p.m. or whatever. And then you can also, it's not too difficult to tie into your monitoring if using Sensu or something like that, looking at response times to be able to run the Deus scale commands from monitoring triggers as well. So it's pretty easy to get to some sort of auto-scaling kind of scenario. And you can see here, I scaled it to 3, I curl it, and it's giving me 3 different container IDs. Now, Deus uses CoreOS and the CoreOS ecosystem to run itself, so I thought I would talk a little bit about this, because it's also another way, if you want to get more into, if you want to have more of like an operator's feel to how you're maintaining things, this is pretty cool. You have CoreOS, which is an OS that was built specifically for running Docker, although now they're doing their own container format, Rocket, and some other stuff. It clusters itself up. So if you run multiple of them, you give it a discovery ID and a URL to look at, and they kind of form a cluster. And running on top of that, it runs etcd, and that creates a clustered key value store. So you now actually have a very easy way to do service discovery and stuff like that by just pushing and pulling items into that key value store. You have Flannel, which is a network overlay, which allows every container to get a real IP address on a backend network rather than having to do the crazy port forwarding. You don't have to use it, but it can be useful. And then Fleet is what actually does the container orchestration. It basically schedules your applications across the CoreOS cluster according to the instructions you give it. And the instructions you give it are in the form of a systemd unit file with some extra metadata. And this is, as I said, Deus runs on top of it, and Deus uses all of this tooling, and it exposes it via a Deus control command, so you don't actually have to mess with it. You just run Deus control, do something for me. This is what it looks like under the hood. So this is a Fleet unit file. It looks exactly like a systemd unit file with the xFleet at the bottom. So it's pretty easy to understand and parse. You can see where it's doing, telling it what Docker commands to run and stuff, to start it and stop it, etc. And at the bottom, you can see it's saying it conflicts with Deus router. And that basically means that it will not start on a machine that already has a Deus router running on it, so that you make sure you don't run more than one of that same container on on an OS. You can see you can do affinity rules, anti-affinity rules. You can do ordering. So you can say, start me up a volume container, and when that's started, then start me up an application container and hook it up to volume container. Kubernetes. So I'm glad someone already talked about that today because I didn't want to talk about it too much. It came from Google, but it isn't Google. It is not Borg. It's kind of this is kind of what Borg is, but we don't really want to share everything about what we do. And it's really more, I see it more as like an equivalent to OpenStack, but for containers. And it actually has a pretty similar user experience to using Heat, right? You have a YAML manifest basically saying what you want inside of what you want to be running, and that kind of information. If you want auto scaling, if you want load balancing and stuff like that, and then it goes and figures out all the hard bits of running it for you. And for that reason, it is not a PaaS. It's something under that layer. And so unless you want to get in the business of building your own platform, which some people do, and that's fine if you're large enough and have the right reasons, but you probably don't. And so I think use an existing PaaS, and wait till someone does create a PaaS or a platform on top of Kubernetes. And I think we'll start to see tools like Deis start to support Kubernetes as an alternative infrastructure to, say, CoreOS. Same, I think you'll start seeing the same thing with Mesos as well. So I think those will start to get really interesting for most of us when there's a platform that we can use to simplify our developer workflows. And then I mentioned Magnum quickly here. Magnum is a newish OpenStack project for running Kubernetes and/or Mesos on top of OpenStack. It is super interesting, but I think it's way too early to worry about it too much. And it also requires Heat, which means you're sort of adding more and more complexity to your OpenStack install. So it's worth remembering that it's there, but we probably don't want to use it anytime in the next 6 to 12 months, except in maybe like a dev test scenario. You're doing a lot of stuff with Docker, right? So you want to have a Docker registry, so you've got some place to share your Docker images, your artifacts. You can pay Docker for the privilege because you probably don't want to just throw them out in the public. Using the private repos, that'll start to cost money. You can run the local Docker registry, which I really like. It is open source, and it can also be backed by Swift or S3, so you don't actually have to store the images on whatever server you're running the registry on. They go out to Swift or S3, which is super useful because then you can run the registry on every single machine you run Docker on in the cloud, and that way you're only ever talking to localhost, and that Docker registry is going out to Swift. And that way you don't have to worry about putting SSL in front of it, doing some sort of client-server keys in front of it, because only localhost can talk to localhost. So you're kind of getting a little bit of implicit security and saving yourself a bit of time there. And it also means you've got a ton of copies of the registry application running. And you can also pay someone for a registry. Both Docker and CoreOS have an enterprise-style registry that you can pay for. And I think, like the open source, they can be backed by Swift or S3. Last couple of slides, I want to talk through a couple of workflows using Docker on top of OpenStack in an interesting way. So this particular workflow I'm using in a couple of scenarios with some applications I help maintain. So you're going to do your development on your laptop using Docker Compose to actually see your work and interact with your work. And then when you're happy, you're going to maybe push it out to your cloud, to OpenStack or whatever, using Docker Compose and Dhaka Machine. And you're going to be able to share that with your coworkers, with your friends, get feedback on it, etc. And then when you're happy with it, maybe you push your code up to Git, and you have a Jenkins job that will then actually build a Docker image out of that and store it in the registry. You don't really want to be taking an image you've built locally and sending it out to production because it's not repeatable. So you want to have a robot that builds it repeatably from your Docker file and from potentially your Docker Compose, rather than you do it manually and just sharing shit around. And then what I do is I use Chef, but Ansible and Puppet both have pretty good Docker integration to actually deploy and run those containers that I've built. And the good thing about that is my Chef cookbook also installs my database, sets up my backups, installs all my firewall rules and all that sort of stuff. So I kind of getting the best worlds. I'm getting to use containers and getting those performance increases with the development time, yet I'm still getting a good solid infrastructure because I'm using the tools I know to set up my stateful data. Second workflow is as you're getting, it's more of a PaaS-like workflow. And this is really where your mode 2 of IT is really wanting to get to give this sort of tooling to your developers so that they don't have to ask IT for things and get things delivered from IT. So what we're doing here, again, we're doing a development on a laptop using Docker Compose. It's pretty much any of your Docker workflows are moving towards doing that. But then when you're ready, you're doing a pull request to your Git repo. That pull request goes up, and Jenkins sees that, and it triggers a run of your unit tests. Unit tests all pass. Jenkins then deploys a test app to Deis, a new one, and it passes back the URL for that. And then either you as the human, or if you've got good test tooling, Jenkins can then run tests against that, make sure it all works, and then mark that pull request as good. And then a human or Jenkins, if you're Jenkins can, if you're that far enough along, to actually pull that request into master. Then when it's in master, that's where you then deploy to staging, and again Jenkins gets a hook from Git that's happened. It deploys it it upgrades your staging app. It doesn't create a new one, so you're testing your upgrade process then, which Deis basically does for you. And then again, you get that opportunity for the feedback loop. So humans are looking at it, probably your release managers are looking at it, marketing people are looking at it. You're getting sort of more buy-in that it's ready for production. So everyone's happy, it's ready for production. In GitHub, you then cut a release. And when you cut a release, it again talks to Jenkins and goes, okay, we've cut a release, I'm going to deploy this to master. So it again goes out, uses Deis to actually then upgrade the production app to the new one, and then you can, and you're done, you're live. And if you have problems, Deis has a rollback tool, which you just roll back to the previous version and it skips straight back. So it's pretty easy to roll back when you screw up as well. And that is kind of it. Hopefully I've said some interesting things. If you have any questions, we have 1 minute. We have 10 seconds.
No, it's okay. We can take a couple of questions. Just not, I want to make sure you had time for questions.
Yes.
Excuse me. Thank you.
So great. Security. I know Docker acquired a company to fulfill that part. So could you comment on security between containers?
Yeah, so I mean, security between containers, as long as you're not exposing the Docker socket itself into the container or the Docker port to the container, there's not a lot of security concerns. I would not do it in a multi-tenant environment where you have two people that are potentially hostile to each other on the same machine. But if it's two people that sit 10 desks away, it's probably fine. So it just depends on your security stance inside your org and what you feel is an acceptable risk and what isn't. Other companies have been running PaaSes, public PaaSes on Linux containers for a while. Maybe a little bit more secure than Docker is, but it's still using the same tooling, the same LXC style tooling. So obviously there are people that are willing to take those risks and be okay with it. All right, thanks everyone.